Today we're going to learn how to solve finite life problems involving mean stress. Now let's start with just looking at our stress life curve and remind ourselves that the stress life curve for materials is in terms of fully reversed fatigue, meaning the data that is collected is using that Euler rotating beam test, and the mean stress during these experiments is equal to 0, right? Now let's ask ourselves, well, if the data that we have is fully reversed, how do we solve a problem where we actually have mean stress? If we were doing a fatigue test with mean stress, how do we predict the cycles to failure if all the data we have is fully reversed? And the answer here is for us to use a fatigue criterion and to modify that fatigue criterion to help us find an equivalent, fully reversed stress amplitude. A stress amplitude that is equivalent to being fully reversed so that we can find the cycles to failure. Now, how do we do that? Let's start with an example of the Goodman fatigue criterion. The Goodman criterion is just a linear equation. We've got the stress amplitude divided by the endurance limit plus the mean stress divided by the ultimate tensile strength, and we set that equal to 0. Well, what we can do is we can modify Goodman's equation. We can replace that fully reversed endurance limit with our equivalent stress that we want to find, this sigma AR. And then if we rearrange this equation and we plug in the actual amplitude and the mean stress from our fatigue conditions, we'll end up with that equivalent fully reversed stress amplitude that we can then use in our stress life curve, right? So, of course, sigma A and sigma M, these are knowns. These are from our problem. And then the ultimate tensile strength, we can pull that from our tables to get this amplitude. So now that we've got this amplitude and it's equivalent, it is fully reversed, we can now use it and apply it in Basquin's equation in order to find the cycles to failure for our problem. So we go ahead and replace SF with our sigma AR, and then given our A and B material constant, we can then start to search for and solve for the cycles to failure. Now this process can be performed using any of the other fatigue criterion. For example, we could replace the endurance limit with the equivalent stress amplitude and rearrange and solve for Morrow's in terms of Morrow's equation. We could also use Smith-Watson-Topper and find a equivalent reversed stress, or even the Walker equation. We can do this with any of the fatigue criterion that we have available, right? And that's it.